Okay, next one. In this problem, it is given that there is a river. River is flowing, suppose this is the downstream. River is flowing with 2 meter per minute with this speed. And there are two people, A and B. They are starting from the same point, both A and B. A goes perpendicular directly to the opposite side. Suppose this point is C. And B swims perpendicular. A moves perpendicular to river and B swims perpendicular to the river. If it swims perpendicular, that means its own velocity which it has, it is perpendicular to the river, and there will be other component due to the drag of the river, so B won't go perpendicular. If A has to move perpendicular to the river, then A has to swim at an angle. We have discussed it. So A actually moves perpendicular to the river, but B swims perpendicular to the river. So it will not go perpendicular to the river, but it will try and generate its own velocity perpendicular to the river, but due to some drag it will not go perpendicular to the river. So maybe B will land up somewhere here, and rest of the journey B will again come back to C. A goes directly to C, B will swim in this path and then will walk or run and come back to C. So what is given here is flow of the river is 2 meter per minute, and speed of these two swimmers, A and B, while they swim is 2.5 meter per minute. Now what you have to find out is if A and B reaches to point C at the same time, then what is the velocity with which B actually walks the shore from this point to reach to the point C? Okay, so it's a nice problem. Work it out, give some time to it and get your answer. Okay, let's solve this. Answer, by the way, would be 3 meter per minute. So if you have got the right answer, you can jump the discussion and go to the next problem. Answer would be 3 meter per minute. Congratulations to all of you who have got your answer right. You are really learning the relative velocity well. Okay, the discussion goes like this. If A is going perpendicular, that means A have to jump like this with 2.5 meter per second in this direction, and the velocity of the river would be this 2 meter per second in this direction. Now the resultant of these two velocities from the triangular law of vector addition would be this. Now if this is the resultant, then A will actually go in this direction. So you have to find the magnitude of this. The magnitude of this from the Pythagoras theorem you will find as 1.5. So the time taken for A on going to C will be, if the width of the river is D upon 1.5. Okay. Now, what about B? B is not going in this direction. B is actually swimming perpendicular. So B is swimming perpendicular, and there is some component in the x direction. So time taken for B to go on the other side is D upon all of the velocity is along y-axis, so D upon 2.5. This is the time taken to go on the other side, and the drift which will be caused will be time of the journey into x component of velocity, that is 2. This is the drift that has been caused. If this is the drift and the velocity with which he walks, let that be v, then drift upon v, this will be the time taken for him to come back to C. So total time taken for him is d into 2 upon 2.5 plus this, and that should be equal to this. Fine. If you work this one out, you will get d would be cancelled here, you will get v is equal to 3. Pretty simple. Fine. Okay, we'll solve one last problem in this section.